Okay, it looks like we left off. We did question 7 together. All right, and then we made up a practice question and we worked on that one. Those are probably going to be the most difficult questions that you have on this in this whole section, in my personal opinion, because I think a lot of the rest of these you'll do well at. So if we need to practice, does anybody think we need to practice any of those 2 examples after we get done with the rest of the notes? Any of this stuff where we have the fractional exponent, we change it into radical form? I mean, you guys did a very good job, I felt like, in class on Friday. I think more of our time this week needs to be focused on the other part of the test that you just got that quiz back with. Okay, question 8 here. Where do you think I need to be putting this 10,000 cubic feet? Do you think that is V for volume or D for diameter? V for volume. Hold on a brief moment. So anyway, you're right about division. So 10,000 divided by 0.524. You should be practicing along with us, please. That way you can do this on your own instead of acting like somebody else has to do it for you. So what number did you get? Somewhere north of 18 grand? What do you got? 19,083.97. Okay, 0.97. All right. Now here comes the part that Miss Howard was asking about. How do you take a cubed root? She was specifically using a graphing calculator. And let me grab my camera off here so you can see mine. Set this up. Start that. Let's see. I wonder if that'll help or okay, no matter whether you're using a scientific calculator or a graphing calculator, the first step for finding any root is to type the index. Since we want a cube root, we're going to type a 3. Okay. Now some calculators, some of the newer style calculators, you'll type a 3. Oops, sorry, I should have just typed a 3. Now on the graphers, you will go to the math button on the far left side of the screen, or on the left side of the calculator. It says math, and it'll bring up menus like this. Now you might notice that the 4th one down on both of these is a cube root, but I want to mention the next one down below that. It's the x root. Now on an old style graphing calculator, it just puts a symbol on the calculator like that. With the new style, it actually takes the 3 and puts it in the place where it looks like the index. Right, Mr. Moore? Yes. Now, if I want the cube root of 19,083.97, that's all I need to do is type that in. Most of your scientific calculators are probably going to look more like that one right there. Unless they're just... So we should end up with a diameter of 26.7. Does that help? Just hitting that math button. But type the index that you want first, and then hit that xth root. And on the scientific calculators, there's different places. Now, Mr. Singh, the one you have, the old school version that I had when I was in high school, you actually have to hit the, I believe you type the number and then hit the cube root, or hit the xth root, and then type the number afterwards. What? Okay. All right, so I'm thinking I need to do this. Let's see, 19083.97. And then I do the xth root, which is right above the y to the x button. And then I type a 3. Should get the same thing, 26.7. So old school calculators, you had to do it the root afterwards. Versus most of you have the newer scientific calculators, which allow you to do that before. Okay. Back to this. So when we took the cube root, we ended up with a d value of approximately 26.7. Okay. And that's what we're looking for. Don't get hung up on pi over 6. It's just a number, folks. You can type pi divided by 6 and let the calculator find the decimal for me. All right, now. How do I solve this one? Is the radical, I kept asking you this last week, is the radical by itself, yes or no? No. So what are you going to do? You're going to subtract 3. Okay, so we do this, and now we've got the radical by itself. Okay, now what are we doing to both sides? We already got that part. We subtracted the 3. What do we do now to get rid of the radical? We have to square both sides. That's what you guys told me to do last week. If you do it to one side, you got to do it to the other. Okay, now on the right side, it's easy. The radical and the square are going to cancel each other out. What happens on the other side? What is, let's see, x minus 3 times x minus 3? How do we multiply binomials together? Okay, now, yeah, it's FOIL, right? I got a question for you. I was thinking about this over the weekend. I know you'll probably think I'm weird for thinking about math over the weekend, but do you remember when you were in elementary school and we would ask you to do things like 25 times 13? What would you do with the 3? What would you do first with the 3? You'd take 5 times 3, right? And then you'd write down 15 and you'd carry the 1, right? And then you do 3 times 2 is 6, and then you add 1, right? So then you'd get 7, right? And then what would you do? You'd put a 0 in here, and then you'd do 1 times 5, and that would be 5. And then you do 1 times 2, and that would be 2. And then what would you do down the columns? You'd add the like terms, right? So, you know, what a nice trip down memory lane that is. Okay? What is negative 3 times negative 3? Negative 3 times negative 3. That is 9. What is negative 3 times x? Negative 3x. What's x times negative 3? Look, remember, you put a 0 in just like you did over there, right? And then what's x times x? X squared. What do you get? X squared minus 6x plus 9. If we did multiplication like that, would that be useful to you? I mean, yes, because some of you were doing fine drawing your arrows, and some of you still weren't doing that part right. So I'm trying to think in my mind, what's another way to show them if they don't like the box and they're struggling with FOIL, how can I get them to see what it looks like? Is this useful or not useful? Is it? I can do it that way. You can do whatever way you want to do, right? Okay, I love the box, but you draw the arrows, I'm perfectly fine with that. Okay, there's nothing wrong with it whatsoever. I just was trying to think of something else that would help people understand. Okay? All right, now. We haven't done a question like this in a while. You have a quadratic. In fact, this might be a tougher question for some of you than some of those other ones. All right, now, what am I trying to indicate to you with these arrows? Push everything over to one side. Now, why would I do that? Okay, if I did that, I would have x squared. If I subtracted 2x, how many x's would I have? Negative 8x, good. And then 9 plus 6. What's 9 plus 6? 15. Now, if I did that, the other side would be a good old 0. Why would I do that? I've got a quadratic set equal to 0, folks. We need to use an F word here, and it's not the one you're thinking of. Factor it, thank you very much. Factor it. Okay? Okay, do that now. Show me how to factor it. Sorry, I was a little bit off screen there. Okay, I'll pause this while you factor. If you were getting it correct, you had x minus 3 and x minus 5. And when you set the factors equal to 0, you end up with 3 for one answer and 5 for the other answer. Okay? Now, I'm going to do something for you that may, well, we're not going to worry about this instruction right here that says check for extraneous solutions, okay? So we're not going to, so every time you come to those, I want you to ignore that, all right? Now, the truth of the matter is, sometimes you create solutions that don't exist. But I'm not going to get hung up on that for now, because we want to make sure we can go through the process of solving. Now, when I ask you, is the radical by itself, you might say, which radical are you talking about, Mr. Staley? Well, the key thing is we want to have one radical on one side and one radical on the other. Now, you might think that this is more difficult than other questions. When you put one radical on one side and one radical on the other, so I got 10y plus 2 equals the square root of 9y plus 5. I've often asked you, what do you do to get rid of the square root? And what did you say every time? Square both sides, right? What happens when I do that on both sides? No more radicals. So this question's way easier than the last one, because now it's just a matter of doing your basic algebra, moving your y's to one side and your constants to the other. So if I take away 9y's, I'm left with 1y on the left side, and what am I left with on the right side? 3. Yeah, that one's much easier than this last one. We'll probably have to practice another one of those. Let's try this. So, if I do this question on the test, this next one right here will be extra credit. Okay? And I'll show you why. So if I ask you to get the radical by itself, you're going to push this one to the other side, right? So that'd be plus that right there. We can get rid of that. Let me write this down over here. The square root of 4y plus 16 equals Let's do this. Let's put the radical first and then the plus 6 after it. I know those can't be combined together. So you might say, okay, Mr. Staley, you told me to get the radical by itself, but I got two radicals and then this extra stuff right here. So I can't really get the radical by itself. So this would be an extra credit question. So if you square both sides, in fact, I might not even put this one on there because this might confuse the crap out of you. So if I go through the FOIL process, folks, and if I do what I did before, let me see if I can give myself enough space to do this FOIL. So I got, and you can draw your arrows. For you that draw arrows, you're just going to have to write that thing out twice. All right, so I'm going to multiply these two things together. And what's 6 times 6? 36. 6 times that is 6 times y minus 5. Multiply that times that, 6 times radical y minus 5. And y minus 5 times y, that would be just plain old y minus 5. And what you're seeing here is that there are more than one term. So for instance, we got a y. This minus 5 and this 36 can be added together, right? So that would be like a 31. And then I've got 12. I don't think I should put this on your test because to walk you guys through this one is more trouble than it's worth. This thing right here is 4y plus 16. Now, I probably won't finish this one. If you really want to try to tackle this one, go for it. But in order to do this question, you would have to push that y over to that side and that 31 over to that side, creating 3y. Let's see, 16 take away 31, that'd be negative 15 equals 12 times y minus 5. Okay, now just answer me this one last question, and then we'll abandon ship on this problem because it's got too much stuff going on. So we squared both sides, and we got all this crap down to this point. We still have a radical left. What are we going to have to do? We're going to have to, we will have to, divide by 12 is not a bad idea. And then we're going to have to square it again. That's why this would be an extra credit question. All right? So don't think you have to go, this is, the double squaring thing sometimes happens. This one is fairly ugly. So I do not expect you to go through that one. All right. However, the radical is by itself here, so you can square both sides immediately on this one. Of course, that one side is x plus 1 times x plus 1, which would be 1x, x, and x squared. So I would get x squared plus 2x plus 1. And then on the other side, when the square and the square root cancel out, I get x squared plus 19. Now, is this an easy question after this point? Do you see anything that cancels out from both sides of this equation? Now that we've got, now that we've squared both sides and got rid of the radical on the left, and we foiled the stuff on the right, is there anything that cancels out immediately? You got it. The x squareds are now gone. So you have 1 on both sides. Now you can tell me that you're subtracting an x squared, but it just cancels itself out. So now I'm going to move that to the other side, giving me 18 equals 2x. Anybody know what x is? 9, right? If you divide by 2, you get 9. So that one's pretty easy. I like that one. That's a good test question. But definitely I should mark that. That one was extra credit. Don't worry about that one at all. If you don't want to. We might have to do another one on 9. Let's make up another one like 9 to work on. I should probably try to make one with nice numbers, so I don't get something that's nasty. Yes, I probably should check your notes. And let's see, that would be, yeah, 3 would work. And let's see. Yep, we're going to be working on a practice test tomorrow, and then continuing to practice on Thursday, and then real test on Friday. So let's see, 3, I would make 3. Okay, so here's one last question for you to work on while I'm coming around checking. So we got radical 5x plus 1 equals x plus 1. Okay, tell me what your first step is before I start walking around the room. Square both sides because the radical's by itself. Okay, square both sides. Okay, let's see if you squared both sides. On this side, we'd have 5x plus 1. What would we have on the other side? X squared plus 2x plus 1, right? If you need to do it whatever way, whether you use a box, or whether you sit here and multiply out using the same method we did in the elementary school, or if you just want to draw arrows, it doesn't matter. You just need to think about that times that, this times this, and this times this, and get your like terms. Anyway, after that point, what are you going to do? Probably push everything over to one side. That would give me x squared plus how many x's, or should it be minus? Minus 3 x's. Okay. And the ones cancel, don't they? All right. So can you factor that? Any greatest common factors? Yes, there is. What's the common factor between them? X. And so if you pull that out, what do you get? X minus 3. So there are 2 answers to this. What are the 2 answers? X is 3. That's one of them. What is the answer that you get from that first one? What's the only number? Say it louder. 0 is the only number in the universe you could plug in there, which would cause that to be a 0 and multiply and create the whole product to be 0. So those would be the 2 answers to that question. Thank you for working so hard today. I appreciate your time.